We will discuss about the specific heat of a gas. Specific heat of a gas is defined as the amount of heat required to raise the temperature of 1 gram of gas by unit degree Celsius. Why it is different from the solids and the liquids? Here, the solids and the liquids have got small value for the coefficient of expansion, but the gases have got a large value for the coefficient of expansion. That means the gases expand more than the solids and liquids. So when we talk of specific heat of gas, we have to take the expansion of gas into concern. Taking the expansion of gas into concern, we have got two specific heats of the gas. One is called as specific heat at constant volume. Specific heat at constant volume, that is called as CV. This specific heat at constant volume is defined as the amount of heat required to change the temperature of 1 gram of gas by unit degree Celsius, but at constant volume. And another is specific heat at constant pressure. The specific heat at constant pressure, as the name suggests, it is equal to the amount of heat required to change the temperature of 1 gram of gas by 1 degrees Celsius. Here the volume is not constant, here pressure is constant. It is defined as Cp. So we are having two specific heats for the gas because of the large coefficient of expansion, unlike solids and liquids. We have got Cv and Cp. Now we will see what is the relation between the Cv and Cp. To obtain a relation between the Cp and Cv, that is specific heat at constant volume and specific heat at constant pressure, we have got 1 gram of gas contained in a container, and that gas has got the state variables as P, V and T. Now the gas is heated firstly under constant volume and then under constant pressure. Now talking of the first law of thermodynamics, the first law of thermodynamics states that the heat given to a system is equal to change in internal energy plus work done. The heat given to a system does two things. One, it changes the internal energy. Second, it does some work. Let us take first case, constant volume. At constant volume. At constant volume, as delta V is equal to 0, that means delta Q is equal to delta U plus 0. That means at constant volume, whole of the heat is used to change the internal energy of the system. So in this case, delta Q is equal to delta U. Why? Because it is at constant volume. At constant volume, delta V is equal to 0. At constant pressure, delta Q is equal to delta U plus P del V. Now at constant pressure, let the heat be delta Q dash and the internal energy be delta U dash. But in both the cases, as the temperature goes up by 1 degree Celsius in this case and 1 degree Celsius in this case, that means the change in internal energy is the same, as the change in internal energy wholly and solely depends upon the temperature. So if the change in temperature in both the cases is the same, the change in internal energy in both the cases is the same. That means we can have this delta U dash is equal to delta U, as delta T is same, as delta T is same. So delta U dash is equal to delta U. At constant volume, we have delta Q is equal to Cv into delta T. Delta Q is equal to Cv into delta T, and delta Q dash is equal to Cp into delta T. Now we have, in place of delta Q dash, we will substitute Cp delta T is equal to, in case of delta U, as delta U is equal to delta U dash, as the change in temperature is the same, the change in internal energy will be the same. So delta U will be equal to delta Q at constant volume. At constant volume, this delta Q is equal to Cv delta T. So Cp delta T is equal to Cv delta T plus P del V. From ideal gas equation, we know that PV is equal to nRT. So we have P del V is equal to nR delta T. Cp delta T is equal to Cv delta T plus nR delta T. If n is equal to 1 or 1 mole, so we have Cp delta T is equal to Cv delta T plus R del T. Taking delta T as common, so we are left with Cp is equal to Cv plus R into delta T. This delta T and delta T goes That brings us to conclusion that Cp minus Cv is equal to R. This is the relation between the specific heat at constant pressure and the specific heat at constant volume. That is Cp minus Cv is equal to R. That means the heat required at constant pressure is more than the heat required at constant volume, because we see that at constant volume P del V is equal to 0, so no work is done. At constant pressure P del V is not equal to 0, so work is done. That means the heat has been changed wholly and solely into the internal energy in case of constant volume, but in case of constant pressure the heat supplied to the system brings change in internal energy as well as work is done by the system. So Cp is greater than Cv, and their difference Cp minus Cv is equal to R. Thank you.